Hello everybody and welcome back to another C++ programming exercise, and in today's video we are going to be going over programming exercise number 15. Now programming exercise number 15 says redo programming exercise number 14 by first sorting the array before determining the array elements that are the sum of two other elements. Use the selection sort algorithm discussed in this chapter to sort the array. Okay. So basically what it wants is it wants you to sort the arrays before doing it. Now, doing this, we're going to use the selection sort function that we used earlier on in this chapter, and actually some examples. So you can actually go and copy and paste that, but we're going to actually more or less kind of edit it, if anything, slightly, in order for it to be how we want it here, but it's really going to be almost the exact same as it was in the original, how it was written before. So let's get to writing it down. So first we need to write it up here as void selection sort. Selection sort int list, comma, length. Oh, it's also supposed to be int length. Now after you do that, you can go to the bottom and declare the selection sort function. Now what the selection sort function is going to say is you can actually just copy and paste what's up here at the top, and then just write in the parentheses. Write in int index, int smallest index, int location, and int temp. And now for index is equal to 0, index is less than length minus 1, index plus plus, now we're going to write in smallest index is equal to index, and now we're going to have the for loop here that's going to actually sort these. And now for location is equal to index plus 1, location is less than length, and location plus plus. And now if list location is less than list smallest index, smallest index is equal to location. And now temp is equal to list smallest index, list smallest index is equal to list index. And now list index is equal to temp. So that is the selection sort function. Oh, actually, I missed the semicolon right there, and that should be it. Oh, and by the way, usually this function is divided up into two steps. Step A and step B. Those are the two steps that is divided into. So basically what this does is it automatically turns the smallest index into the index, and the index is currently 0, so that is the smallest index, and it does this for each and every single index. So now it does this loop, which is for the location is equal to index plus 1, which is the next index after, which is basically the index after the index that we are currently on, and the location is less than length, then location plus plus, and now if the next location is less than smallest index, then smallest index is equal to location. Which basically means that if the next location is, equal to smaller than the smallest index, then smallest index is equal to whatever the location is equal to the next index, which is the location. This may be a little bit confusing, but I'll just have it like this. 0, 1, 2, 3. Let's say that this is index, and this is going to be location, which is index plus 1. And since this is smaller, then nothing will happen. But let's say we rearranged it, and it was a little bit more like that. Then it would be, and when we would have that, it would be, this would be the new smallest index. That's basically what this loop does. And now what it does is it finds the smallest index, and it finds this each and every single repetition of this for loop. Now the reason that the smallest index is so important is I'll get to it in a little bit later. It actually is important here in step B. So in step B, what happens is that now we set temp to the smallest index. Now the smallest index is equal to index because, smallest index is now equal to index because that is going to be the index that we want to start from now. And now list index is going to be equal to temp. The reason for existing of temp is because we want the current smallest index to be equal to the new index, and we want the smallest index to now be equal to the index. And that's basically why we have temp, because we have to put the value smallest of a list with index smallest index in there, and then we'll be able to put it like that. So basically what this does is, let's say that we had these numbers which were not in order, 6, 4, 9, 10. What it will do is they'll search through this, and it'll find what is the smallest index. And now it will highlight that, and that is step A. It highlights it, and then it moves on to step B, which is, of course, changing up the values. So what these changing of the values does is it deletes 4 from there, and brings it over there, and makes the starting index, or where we start, from here. And then it moves on, highlights what it is, and now it goes through all of this, and if nothing changes, like there's no new smallest index found, then nothing actually changes. And there we go. Now the function is complete. Now I hope you guys understood that. Because, to be honest, this is a fairly complicated array sorting program, but once you get used to it, it should not be too good. I mean, it should not be too hard. Now, once you're done with that, all you need to do is type in right here, selection sort, list, comma, list size. And after that, you are done with the program, I think. So if we just run this, let me just take what we have right there, shrink it, and now it should be sorted. Yep, it does seem to be sorted. You see, each one of those is the smallest index. Okay. Now I hope you guys had fun doing this programming exercise along with me. And I'll see you guys in the next video. This was a pretty fun exercise, and I'll see you guys later. Bye.